Good morning, Australia. This is going on with the Barker Extension 1 Semester 1 exam. And we're in question 11 in the working zone now, where we're doing our working out questions. And this is one with inequalities. And the question is, find the values of x, or solve the inequality where this statement holds true. 2 over x minus 1 is less than or equal to 1. Now, as per this huge box that I've just got here, a concept that we're going to be using, and it's actually going to make things a little bit more difficult for us, sadly, in this question. But I think it's a fascinating idea, and the way we get around the problem that this little box poses is genius. So I'll crack on with it. So when multiplying or dividing by a negative number, so if we times this inequality by or divided it by a negative number, we would have to flip the inequality sign. So if I was to times both sides of this inequality sign by -1, it's like a mathematical law that I would have to flip the sign from a less than or equal to sign to a greater than or equal to sign. Now, how is that relevant? So first of all, I'll just rewrite the question. Less than or equal to 1. Now, what usual protocol would be if this was an equal sign and we're just being asked to solve it, is we would times both sides by x minus 1, because that would get rid of this x minus 1 on the bottom, and we'd be left with it over here, and then would be closer to making x the subject. However, the problem is this x minus 1 takes on a whole lot of different values. So if we're chucking in x equals 1,000,000 here, we're going to have a big positive number on the bottom, and then we times both sides by, you know, 1,000,000, basically 1,000,000 minus 1, and then we'd be fine. And we wouldn't, because 1,000,000 minus 1 is a positive number, we wouldn't have to change this sign. However, if x is 0, then we've got a minus 1 on the bottom, and then we're timesing minus 1 on both sides, then we would have to flip this sign. So there are some cases where we'd have to flip the sign, and some where we wouldn't. If we just multiply by x minus 1, what do we do? How do we get around that problem of whether we have to flip the sign or not? Right, think about a solution. It is genius what we do. So we times both sides by x minus 1 squared. Bloody clever. So x minus 1 squared on both sides, and that's because I've just times, there's a 1 here at the front. I'll draw it there for you. And the reason why that is really clever, because x minus 1 all squared has to be a positive number, because no matter what you've got in here, whether it's negative or positive, when you square it, she becomes positive again. So we don't have to flip the sign because it's not a negative number, because we know this will be positive. Very clever. So what we're going to do now is we're going to... Oh, so we times both sides by x minus 1 squared. We still had an x minus 1 on the bottom here, recall. So, sorry, that might have confused you. So we've still got this 2 over x minus 1 here. We've just times both sides by x minus 1 squared. So we've done that to the left and the right. Now what that does is, we've got an x minus 1 squared and an x minus 1, so that'll cancel with one of those. We'll just be left with 1. And we're going to expand this out, so we'll get 2x minus 2 is less than or equal to... Now we're just going to square this, so we get x squared minus 2x plus 1. Beautiful. And don't mind what I've got going on down here. I was just being a bit cheeky before we've started. We'll come to that later. So we're going to minus 2x to both sides, so we're going to get, I'll just write 0 for now, so we're just minusing 2x to both sides, so we're getting the x squared stays there, and we're going to get minus 4x, because we're minus 2x to that. We're also going to plus 2 to the left and plus 2 to the right. So if we plus 2 to the left, it goes to 0, I've already written that, and we're going to plus 2 to this side as well, 3. Beautiful. And we'll just have a quick little factorize there. So, excuse me, so 0 is less than... Now, how do we factorize this? We want two numbers that multiply to give positive 3 and add to give minus 4. So, sorry about the suspense there. X minus 3, X minus 1. Beautiful. So, minus 3 times minus 1 is plus 3. Minus 3 minus 1 is minus 4. Beautiful. So, we know we're right. Now, what do we do? How do we solve this? 0 is less than all this. The method that we're going to use here, because I think it's just the most elegant and kind of clever method, and it's much easier, is to graph this function. So I've drawn down here the graph just before we've started of this function y equals x minus 3, x minus 2, or its expanded form up here, which is just before we expanded it. And you can see that it has roots or points where it cuts the x-axis, x-intercepts at 1 and 3, because when you pop 1 in here, this becomes 0 and you get y equals 0. Same for when you put x equals 3. So it's got these roots here. And when x equals 0, you just get minus 3 times minus 1. That's positive 3, so that's why it cuts the y-axis at 3. Now, let's think about this. So where the question was, I'll just write it a bit lower. 0 is less than or equal to x minus 3, x minus 1. That's where we're up to. And we want to know, where is that the case? Now, this is the case. This yellow condition holds true where 0 is less than this, just here and just here. Let me explain why. Because this y equals 0, or x-axis, represents 0, and this represents the graph, this parabola. So at this point here, 0 is less than the graph, or 0 is less than this function here, obviously because it's below it. Similarly, here, when x is greater than 3, or similar to when it was x is less than 1, 0 is less than this graph. So this condition holds true when x is greater than or equal to 3, this bit, and when x is less than or equal to 1, this bit. So we've used a graph to answer this question. And just to prove that we're right, just to prove that this is the correct answer, what I've done is, remember here, this here, it was just the question. So remember, it's just 2 over x minus 1 is less than 1. That's what we've got here. And just to prove that we're right, we can chuck in a few different values just to check. So when we put in x equals 0 into here, x equals 0 goes in here, we get 2 over minus 1, so that's going to be minus 2. Minus 2 is less than 1, which is the same, and that's true, minus 2 is less than 1, so we're right, boom, it's defined in this area. When x equals 2, so this is our no man's land down here, we didn't have anything in there, so x equals 2, 2 will go in, 2 minus 1 on the bottom will be 1, so 2 over 1 is 2. 2 is less than 1. Bollocks it is. It's not. 2 is not less than 1. So this no-go zone. We were right in saying that this area is not solving this equation. And when x equals 5, we've got 5 minus 1 on the bottom. So that's 4 on the bottom. 2 over 4 is, of course, a half. A half is less than 1. Yes, it is. Boom. So we're right. So in these two areas is where we're correct. So when x is greater than or equal to 3, that's this one, and when x is less than or equal to 1. Fantastic. So that's the question done. Just a quick little point on the side. You might say, how come you've got these equal signs? Why is it greater than or equal to instead of just greater than? Now, a good little trick to remember is, the teachers might like me telling you this, but if it's a less than or equal to sign, if it's equal, odds are 95% of the time you're going to have a less than or equal to sign in the question. But just to be mathematically rigorous and think about it, we're saying, where is 0 less than or equal to this function? And at this point, x equals 1, it is equal to it. This 0, at this point here, this graph takes on exactly the value of 0. So 0 is less than or equal to it. It is equal to this point here. So that's why we've got the equal sign. But I hope that was clear. It's an interesting little video, I think. Interesting, well, if I don't say so myself, interesting little question. I hope it was clear. See you in the next one, guys.